Hello, and let's talk about the downtimes and why they're important. You probably heard a lot about the term the no downtime deployment and the requirements that come from this, but why it is important and who needs it. So let's quickly discuss and do some experiments, shall we? Obviously, that requirement to have a no downtime deployment comes from the business and maybe just a little bit from the overblown sense of perfection from the developers. That's why we like to do the refactoring again and again, right? But anyway, getting back to the business talk, there are those nice promises that are called the SLAs or service level agreements with the customers, and those are the promises basically that your service will be up and running for a number of time every day, every week, and usually you probably heard it many times. It is expressed in the number of nines or just some sort of a percentage. And over here, let's take as an example 3 nines. It will mean that every day you can have only 1 minute and 26 seconds of downtime for your application. And by downtime here, I mean that the application is not available, not reachable, and customers cannot use it. And obviously you want to keep your customers as happy as possible and don't break those promises, so they will continue to pay or to continue to use your service. And that 1 minute 26 seconds, it's quite a short period of time. Obviously it means that there is a downtime that you cannot have longer for 1 minute every day. And if your application is just super stable and keeps on running, then this time budget, it keeps on increasing. And if there is a single incident that happens only once a month, you have a whole 43 minutes to fix it and redeploy the fix back to production. But that's quite a good case scenario. And if we are talking about the live application that is still being developed, and you have a continuous deployment implemented or want to implement a continuous deployment practice and try to push every commit to production as soon as possible, and probably you do more than one commit every day, then in order to achieve that 99.9% availability, then your commits cannot make your application to be down for more than 1 minute and 26 seconds every day. And then you have basically no room for the actual exceptions where your application is down. That's why you might want to achieve the no downtime deployment as soon as possible, and probably before you go to the continuous deployment route and have those SLAs publicly available and promised to your customers. Because even if each of your deployments would cause only, let's say, 10 seconds of a delay because your application is restarted, then you can run only 8 deployments a day, and then there should be no exceptions whatsoever. And we don't live in a perfect world, and there could be some issues from your service providers or something else, and it still would affect your SLAs, and your CEO probably wouldn't like that kind of a discussion with you, and you wouldn't like it either. So in order to get to this, there are a lot of options to check how your application is running and how much what is the availability of it. For example, in the Azure DevOps, there is App Insights available that has availability metrics, but it's not very cheap because you need to consume a lot of logs. And obviously there are some additional extra services that you can use and provide some dashboards to your customers. For example, I just found that Jelly HQ website that is quite nice, and it has a free tier that is called Hobby that allows one person to have API checks to run. But then again, over here you have the API check run that is limited for the Hobby tier for 10,000 runs per month. And if we would check how many minutes in a month, then there would be 43,000 of minutes. And if we would want to go to something closer to those 10,000 runs, then it would be about every 5 minutes you can run one API check, and that would be 8,700 of checks. So with that being said, you can combine all of that and see that with a hobby tier, you would be able to achieve or verify that your application is up and running only every 5 minutes, which is not good for that SLA of 99.9, and that actually would be closer to 97.5. That one for the front ends. I jumped a little bit because there are the browser checks, and the limit over here is 1,500 per month. But for 5 minute interval, it would be something closer to 99.5. Yeah, so it would be in that range. Still, it's a great figure, and you just need to be open with your customers what you can provide to them. But enough about the dashboards and what is possible for Checkly, especially that if we would scroll down and in the FAQ section they explain that what is an API check run, and still the check run have a timeout threshold of 30 seconds. So even if your application would be down for 29 seconds, for example, and after that it would be recovered, then Checkly API check wouldn't pick it up, and it would obviously not count the SLA correctly. So first of all, what you need to do is you need to prove that your application is running as you want it to by yourself, and have some sort of a proof that when your application, let's say, is redeployed, then it is not down for too long, and you can apply fixes quick enough to not blow out that SLA budget. So in order to achieve that, let's do a little bit of experiment. And for that experiment, I have an application ready that is a backend application. It's a Java application for my case, because Java usually starts a little bit slower than, for example, Angular application. So we are going to play around with this one. And in order to see the results, I prepared a little bit of a PowerShell script, which just tries to indefinitely ping my health check endpoint of that web app, and give the host name of the application that it is returned, and if there are any exceptions happened, then it's going to output that as a result. The interesting bit about this is that I'm setting the timeout of this request to 10 seconds, because by default actually the invoke web request command, it doesn't have any timeout specified, and it will just wait forever for the application to return, which is not what we want to achieve. And just as indication what we will receive, let's quickly check what that endpoint is at the moment. So when we go to that pizza selector backend dev and get the custom health end check, there is a random component that is writing the host name of my application where it is running right now. It also has a database status to be checked and the disk space, so that is the usual stuff. And to actually see what is the results, let's start it. And basically every second, because I am sleeping for 1 second here, it will output what is the name of the host right now. Basically it means that the application is running correctly and returning 200 response. So with that being said, I'm going to clean this screen, and what I want to do is to rerun the deployment of this application. So I'm not going to use any different builds or anything else. So just let's run that workflow again, and it will rebuild the application again. So it will have a new version of the image, and that new image would be deployed to the web app. So I'm going to probably skip a little bit right now in time, so while it is building, and as soon as it will start to deploy, I will come back, and we will start this script running in parallel, and we will see some interesting results probably. I will comment as we go. Okay, now the application is built, and now the deployment step is started, so I will start this script to run, and we can check what's going on in here, and keep an eye on our application, how it is running. So the interesting bit will start to happen somewhere over here, and spoiler alert, it will actually happen a little bit after that. So right now the deployment is passed, and it is saying then that the application is restarted completely, and everything is good. But as you can see from this output, actually the application is still running on the same container as it was before, and the host name hasn't really changed, which means that it is still running the old version of the application for quite a while. Let's just pay attention to time, so it is 2:56 and something, and it is still going on and on and on. Now it's getting a little bit slower possibly, but just a latency. But anytime now it should actually change the host, because it will be running a new version of the application at some stage. And there it is. As you can see, there was a timeout. This timeout happens basically because of the load balancer, and the new version of the application is actually available, and it started, but it's not still ready to serve the traffic, because in my case it probably just runs the liquid base, and as I said, Java applications, they are not the fastest to start, and still here we have some timeout operations which are very interesting. And after that one is finished, in some time we will get the responses hopefully from the new host. There we go. So for now it still hits, as you can see, the old host, and that is how, as I said, load balancer works. And soon that old host, that old container should be destroyed, because here it was trying to reach the new one, and it was failing from the load balancer perspective and from our perspective, and here it still was reaching out to the old container, probably because of the session affinity. So most likely there are some sticky sessions, but we don't really know the internal implementation of the load balancer from Azure. And somewhere right now it should probably kill the old hostname, and we should start receiving the responses from the new host. Let's wait for it. A bit longer maybe. Okay, there it is. we finally hit our new host, and it means that the old one is gone for good, and now all of the requests will be served by this E057. And as you can see, it took almost 3 minutes after the application was actually restarted to start serving the traffic from the new host. And possibly if we wanted to deploy, for example, some sort of a critical fix that needs to be deployed as soon as possible, we would have at least 3 minutes, maybe downtime, but it's up to you to decide what would you call a downtime. But over here, the responses, they were not really stable for some time, and as you can see, it started at 57, probably almost exactly 2:57 exactly that timeout started, and they were going back and forward for about 1 minute, and even after that there were some intermittent timeouts as well, which are not good. And as I said, for that SLA, you want to improve on that, and do not have any sort of downtime and inconsistency like this. And maybe I will show a little bit more. Let's do that same experiment, but instead of just running the deployment, we are going to start that same monitoring script, and we are going to restart the application using this restart button. The results are quite interesting, and that's why I don't really like the restart button. As you can see, I clicked it maybe somewhere around here, so 3:30 seconds, and the traffic is served from E057 still, and I will skip forward in time right now until we actually start getting the responses from a new container, and I will show you what happened in a meanwhile. Okay, and as you can see, it's now 3:04:39, and just as a reminder, we started at around here, so 1:30. It took almost 3 minutes to get to a new host, and once again there were a couple of timeout exceptions, maybe for, let me stop this so it doesn't keep on going, so maybe for about 30 seconds or so there were some timeouts even after the restart while the application was feeding the new one. Those timeouts, they are not consistent, and sometimes they will be present, sometimes they will not be present. But what is very interesting for me is that to change the host it took 3 minutes, sometimes it is even longer than that. And for me it's very annoying behavior when you want to see some changes in your application behavior. So you could, for example, change the database, and the database updates only initiated during the application startup or something like that, and you want to restart that application to see the changes, and you need to wait for unknown amount of time, somewhere between 3 and 5 minutes, to the application to be actually restarted. So let's show a little bit different behavior. Over here I will start it once again anew, and what I'm going to do now is I'm going to stop the application, and as soon as it is stopped, quite soon we will start to get a new type of a response. So we started at 3:06:26 or something, and 20 seconds later it is returning 5:03, so the application is stopped. And if we start it again afterwards, it would basically mean that if you try it on a browser, you would get that blue screen that the application is stopped. And when we start it again, as I said, it will give a new response quite soon. So now the application is starting, and the whole restart that way, it is getting a little bit faster, and here is a timeout different from this. So it means that the application is actually starting right now, and the container starts my Spring Boot application. and quite soon, and by quite soon I mean almost now, maybe, pretty please. Yeah, I have a feeling it will happen now. Yep, there we go. At 7:58 now, the application is started on new host, and the traffic is flowing as it needs to be. And that whole thing took only maybe 1.5 minutes, and quite often it is much faster than even than that. So as you can see, it's at least twice as fast and much more deterministic. So you would be able to see that the application is actually stopped using just a single click of the mouse, and then you can see the new application is actually running. And one more note before I wrap it up is that I'm still running all of that on a free tier of the application, so it's not the most performant one. But anyway, that's a good thing to keep in mind, that there is a downtime even during the deployment, even during the restart. It might be just postponed in time, but there is things that you need to consider and you need to overcome if you want to achieve the continuous deployment with zero downtime practice. Thank you for listening, and have a nice day.